Hello children, how are you all? Welcome back to the 7th General Science class. You have gained a good knowledge of the uses of the soil, properties of soil, what the soil contains, and 2 activities from the previous video. Today we are going to learn about kinds of the soil from the topic soil. Are you all ready? Learning objectives. In this video, we are going to focus on identifying the types of the soil. To find out the moisture content in different soils. We learn how to check the percolation rate of the soil through an experiment. We will check the water holding capacity of different soils through an experiment. We will enjoy some activities related to soil. Keywords: mold, proportion, percolation, moisture, capillary spaces, aeration, sand, clay, loam, dripping, concept map. Let us start this video with an activity. Activity 1. What type of soil is it? Take 20 grams to 25 grams of soil from your soil sample. Remove the pebbles, grass, and other organic matter from it. Knead the soil by adding water drop by drop and make small balls of soil without the soil sticking to your palms. Make a 2.5 cm diameter ball of soil. Put this ball on a flat surface and try to roll it into a 15 cm long rod. If you can bend the rod without breaking it, then bend it into a ring. You can identify a soil type by the extent to which you can mold it. So, in this way we can identify the different types of soils. Determine the soil type based on the following chart. If the proportion of larger sized particles is greater, we call the soil sandy. If the proportion of fine particles is higher, the soil is clay. If large and fine particles are present in equal proportion, the soil is called loam. I hope you all understand very clearly. Now we should know why different soils are behaving differently. This is just because of the moisture content present in the soil. Let us see clearly with the activity. Activity 2. There are many ways of finding out the moisture content of different soils. We shall use a simple method. Grind the soil you wish to find the moisture content of into a fine powder. Weigh 100 grams of soil from this pile. Spread it on a newspaper and dry it for about 2 hours in the sun. While drying the soil, the sky must be clear and the heat of the sun intense. Keep turning the soil over while you are drying it. Be careful that the soil does not spill out of the newspaper. Weigh the soil again after it has completely dried. The difference in the two weights will tell you how much water 100 grams of the soil contains. This quantity is known as the moisture present content of the soil. Experiment based on the above mentioned points. Experiment with different soil samples. Write the percentage of the moisture content of the soil samples in the table after the experiment finishes. Are the figures of the percentage of the moisture content of all the soil samples the same? Obviously, this will not be the same. Why? Yes, this is due to the percolation rate of the soil. What is the percolation rate? Percolation is the movement of water through soil, and the percolation rate is the speed at which that movement occurs. Percolation rate is calculated using the following formula. Percolation rate is equal to amount of water ml by percolation time minutes. Take soil samples that were collected for the previous activity. Take a plastic funnel and place filter paper in it as shown in the figure. Weigh 50 grams of dry soil and pour it into the funnel. Take 100 ml of water in a measuring cylinder. Then pour the water on the soil drop by drop. Do not let all the water fall. Experiment with different soils. Which type of soil retains the highest amount of water? The answer will be the loamy soil. because loam provides proper capillary spaces and good aeration to hold water. It has a mixture of sand, clay, and decomposed organic material known as humus. Which type of soil retains the least amount of water? Sandy soils contain less amount of silt, so they hold less amount of water when compared to other types of soils. Which type of soil took the least time to pass down water? Sandy soil. As it has so much space between the soil particles, it drains up water quickly. Which type of soil took maximum time to pass down water? Clay is the densest and heaviest type of soil that does not drain well or provide space for plant roots to flourish. The percolation rate of water is lowest in the clay soil. Clay particles, being much smaller, pack tightly together, leaving little space for air. Thus, the aeration in clay soil is poor. Why does sand soil not retain water for a long time? Sand is made of larger particles and therefore has bigger pore spaces, and water just runs through, so sand has a higher percolation rate. Is there any relation between the percolation rate and water holding the capacity of soil? Conversely, soil with a lower percolation rate, like clay or silt, tends to have higher water holding capacity. The smaller particles in these types of soil mean that pore spaces are smaller and water moves more slowly, enabling it to store more water. Let us see one more activity to see the amount of water the different types of soil hold. Activity 3. Pour water all over the soil surface until it starts dripping out of the funnel. Observe how fast water passes down the soil. Measure the amount of water collected in the beaker. Calculate the difference between amounts of water. Record the time taken for water to pass through the sample. Fill in the following table. Hope you enjoyed the video with all the activities and gained solid knowledge. We will complete the topic by knowing about the horizons of the soil and how the soil is conserved in the part 3 video. Don't miss it. Switch on to the next video. All the best.